What I'm going to do is do a really quick presentation on some of the air leakage characteristics of Canadian housing. My focus is on the housing, low-rise housing up to 3-story. Our motivation for this housing stock database is basically to track what is the response of the housing over the time, mainly on the energy efficiency, also looking at different building envelope characteristics, different equipment, the residential equipment, and the impact of housing codes and regulatory measures as well as the incentives. And the way we have done this particular collection of data and all those things is using some of the retrofit programs, which I will just touch base on it. But before that, I just want to give you a quick overview of Canada's housing stock. In Canada, we have right now about 14 million dwelling units, and about 85% of our housing stock is at least 25 years old. And every year, there is about 180,000 dwellings are built. That's a new construction. When you see our 85% of housing stock is located in British Columbia, Alberta, and Ontario and Quebec. So that's our major population areas. The housing stock, about 58% is single detached, single family homes. There are about 10% which is attached in the sense that they are row houses or semi-detached homes. On the primary energy source, this is mainly for the space heating, is 46% of the housing stock is heated by natural gas and 38% with the electricity. In remote areas and some of the wood is still plays a major role. Now the airtightness requirements, as such in our National Building Code, which is basically a document which is adopted by all the provinces, most of the clauses from that. We, since 1990, we require a continuous air barrier requirements, and there are about 20 different requirements are there. But there is no set value of airtightness, which is considered in the National Building Code. It's mainly the prescriptive requirements that one should do this type of joints, the sealant used and all, but there is no set value or the requirement in the National Building Code or the provincial building codes which requires that certain level of airtightness is required or not. We are, for the upcoming 2012 National Building Code, proposing a set value of airtightness. We are not sure whether that will go through or not, but we have made that request. In the energy code, we have an assumption of 2.5 air changes per hour at 50 Pascal, and that comes from our what you call scanning of airtightness of new housing over last 5 years across Canada. In our what you call best practice R2000 standard, we require that the air change rate is at 50 Pascal is no greater than 1.5 air changes per hour. That's our minimum requirement for meeting the R2000 standard. We utilize in Canada is the CGSB 149.1 standard. This standard originally came on in 1986 and still being used, and it actually provides the information on how to do the test, at the same time selecting the equipment, calibration, and the calculation methods for defining the airtightness of houses. Just to give you a quick overview of this particular test procedure, is that house is prepared, there are certain requirements for sealing some of the what you call not required holes and all, and the standard actually provides that hole details and all those things. And we do this blower door test, which is common in I think most of the other international standards also. Take this data and then fit this particular regression curve in the sense that we can come up with the C and N value and derive the different the air change at 50 Pascal, equivalent leakage area at 10 Pascal, or the normalized leakage area is 10 Pascal, or different the parameters on that one. The airtightness indicators which we use is mainly the air change per hour at 50 Pascal pressure difference, or the equivalent leakage area ELA at 50 Pascal pressure difference. But there are also NLA, which is the normalized leakage area, which is obtained by taking the ELA and normalized as per the surface area of the building envelope, or the NLR, which is the normalized leakage rate. Now, this particular NLA and NLR is generally used for construction quality checks. So I'll just provide you some more information about our database and the analysis of it. We have been, since 1998, we have few of the what you call the home energy retrofit programs, and as part of that one, we do the a typical assessment includes the walkthrough evaluation, gathering the data for the whole home, and also doing the air leakage test. Right now in Canada, we have more than about 2,100 qualified energy advisors who are offering these services under the Eco Energy Homes for Retrofit program. And this particular one also provides some of the financial incentives to homeowners to do the retrofits in the homes, which are also matched by other utilities and the provincial jurisdictions. So we have gathered more than about, we have done actually pre-retrofits of more than about 846,000 homes in last 12 years or so. Mainly, these are low-rise up to 3-story homes. Out of those, there are more than about 634,000 houses have actually implemented some of the retrofit measures and all. So in the database and particularly analysis of the airtightness as well as the energy efficiency measures, we have included about 634,000 homes. The idea for picking this, this one is basically that these houses have been what you call evaluated twice. One was pre-retrofit and after post-retrofit. So we want to make sure that the airtightness test which were done in the houses before and after has some validity in those. Taking this data, we established, we use these 4 different criteria: house types, age groups, climate zones, and type of primary fuel systems to do the evaluations. And then we had about 190 homes from this set of data where we had done a very detailed monitoring, including some of the utility data and all those things, and just verified that the energy consumption in those homes. So just to give you an idea that we are, our sample size is about 635,000 homes, which is about which represents about 5.1% of the whole housing stock. So it's a quite a large database, and although we still haven't done the statistical analysis, but looking at the large size of the database, it shouldn't be far off. As part of our data collection, we collect more than about 220 different variables for the home, which includes the house configuration, formation, and the thermal characteristics, in the sense that all the thermal insulation values, the what you call the areas of different components and all, including the measurement of air tightness using the blower door, and then all the space heating and hot water ventilation and air conditioning systems information. So based on that 635,000 homes, just to give you the data on that one, that air tightness of homes have improved over the years. What this represents is these 25th percentile, 75th percentile, and then the 50th percentile values of from the data sets. So over the years, air tightness has improved significantly. In fact, right now, we have most of our new housing comes around air change rate of 2.5 to 3 at 50 Pascal pressure differential. The houses are becoming more airtight, and that is requiring some of the mechanical ventilation in homes. This is the histogram of that, and what it shows is that particularly the new houses which are built in last 15 years or so, most of the airtightness which we find is below air change rate of 2 or 2.5. The next one is between 3 to 6 is the houses which are in last 20 years, and some of the older homes where the airtightness which we have found particularly is it's more than 7, 8. Just to give you the regional differences, in British Columbia, because of the mild climate and all those things, as you can see, the airtightness levels are much higher compared to some of the prairie provinces. And this shows, again, the analysis of whole 635,000 homes, where before retrofits and after retrofits, what can be achieved through the airtightness. And again, the analysis, this shows the analysis of the space heating energy used in this particular house. Our houses are, because of the retrofit measures and changes to the homes and all, our houses are becoming much more better in terms of the reduction in the energy use. So they are becoming more energy efficient, and even that follows through in different regions also. The level is different, but it is there. So the trend in the housing is, if I take this energy consumption index, which is the megajoule per degree day per meter square of floor area, we have improved significantly over the time. And now our national code, particularly in 2011 and 2012, are requiring the energy efficiency up to a level of R2000. So we have our next generation programs will be looking at much better, much aggressive, what you call energy efficiency measures in the codes and all. So that's my, presentation. What we find that the thermal characterization of Canadian housing stock actually helps us in developing the policies and also providing some of the future opportunities there. And since the houses are becoming more airtight, since 1990 we have mandatory mechanical ventilation requirements in most of our codes, and energy efficiency of our tract housing is improving steadily, but we still find that there are quite a lot of opportunities there. So that's the summary of my presentation.